Okay, we're going to go over the generator of special right triangles. We're talking about the 30, 60, 90 degree triangles and the 45, 45, 90 degree triangles. This should be the first page of your trig book. This is what starts your ratios and all that. So this is an important concept. Now, we're going to take this is supposed to be an equilateral triangle. All right, and I made a height. So I cut the triangle into half, made a height. And let's say since it's equilateral, all the sides are going to be 2. Now, when I do that, please notice that this side, therefore, will be 1. Also in a triangle, all the angles should add up to 180. So if it's equilateral, all these angles here should be 60. But when I cut it in half, when I cut out the 60 in half here, I get 30. And then, so this stays 60. And we have a 30, 60, 90 triangle. Now, what we want to find out is the height. So I'm going to always call the side across from my 30-degree angle A. So in this case, I'm going to use the Pythagorean theorem, and my A is 1. My height is my B, and I do not know what that is yet, because we have to solve for the height. And my C is always the hypotenuse, which is 2. You solve for your height, and I'm sure you can do the algebra here. And so height, 4 minus 1 is 3, so my height is square root of 3. Now, I'm going to go ahead and put a 1 in front of this. You should already know the formulas for the special right triangles anyway. And we're going to notice that my A, which was 1, is the same as this one right here. It'll make more sense when we do another one. So, I'm going to pick easy numbers so we don't have to deal with decimals or fractions. And I'm going to change my equilateral triangle so that all sides are, let's say, 4. In this case, half of 4 would be 2. I'm going to change that 1 to a 2. And I'm going to use the Pythagorean theorem again. Please notice that my A is 2 and that my C is 2 times my A. So 2 times 2 is 4. What we don't know is the height. So we're going to, my A again is 2, so we're going to go 2 squared plus h squared equals my hypotenuse, which is 4 squared. Again, 4 is 2 times your A. Solve for h. Square root both sides. You can't leave it like that. So we know this is 4 times 3. Square root of 4 is 2, so we get 2 root 3. Please notice that, as usual, my A, 2, matches the 2 here. So these match here. These match here. Now, if I change this up and change all this to 6, let's go back to blue. So I have 6, 6, and 6. Therefore, half of 6 here would be, let me change that, 3. What do you think my height is going to be? Did you say 3 root 3? You would be correct. Let's do it very quickly. I have 3 squared plus h squared equals 6 squared. We have h squared equals 36 minus 3 is 27. So h is root 27, which indeed equals 3 root 3. Remember, 27 is the square root of 9 times 3. Square root of 9 is 3, so that we get that. So now you just came up with your formula for the 30, 60, 90 triangle, and our h, in this case, is always going to be a root 3. Okay, the 45, 45, 90 is a lot easier. We're going to call the, since they're both 45 degrees here, the sides are the same. And we have our hypotenuse here. So I'm going to let my A be 1. So instead of A, I'm going to put 1 here. In this case, I do not know my hypotenuse, so I'm going to use the Pythagorean theorem. 1 squared plus 1 squared equals my hypotenuse, which would be c squared. So I get 2 equals c squared, so c equals root 2. Again, I'm going to go ahead and take and put a 1 in front here. In front, this equals my 1 here, which also actually eats my 1 here. Okay? And let's do one more and change this to, say, 2. Okay. We put 2, 2. Use the Pythagorean theorem. 2 squared plus 2 squared equals c squared. 4 plus 4 is 8. So c equals root 8, or 4 times 2, which is 2 root 2, equals c. So again, my a's match here. So if I put, let's see, 3 here, let me erase that. What would be my c? If you said 3 root 2, you would be correct. And this is what generates our formulas for special right triangles.